Today we're learning about polar coordinates. You know how we're used to graphing? We're used to graphing like rectangularly, like going an X and then a Y. They actually call those rectangular coordinates. X comma Y are rectangular coordinates. Today we're going to learn polar coordinates. Now watch carefully. This is amazing special effects that you're about to see. You ready? You like that? Look at that. See, the idea is we're still talking about the same ordered pairs, but we're just sort of putting a new grid over the plane. And so let's talk about the point. Do you see that point I have graphed up here? What point is that in rectangular XY coordinates? Yeah. 0, 3, X, Y in rectangular coordinates. Now if I switch to my other coordinate plane, now we're talking about polar coordinates. So now I want you to think about a radius and an angle at which that point lies. So first of all, radius, you probably know that that's just talking about how far out from the center. So how far out from the center? It's 3. 1, 2, 3. Yeah? Okay. And at what angle have we rotated? We're up at the 90-degree angle. And so we would call that point the point 3, 90. Or if you would rather 3, pi over 2, whatever you're into, that's polar coordinates. We're going to practice some more and see if we can put other ordered pairs onto a polar graph. Let's try 3, 150. I actually like to start with the angle. So I circle myself over to the 150 mark. And then on that line somewhere, I'm going to come out a radius of 3. So 1, 2, 3. This is the point 3, 150. Does that make sense? Okay, let's try another one. What if you have a negative angle? Yeah, you'll rotate the opposite direction clockwise. So we're going to go down to, is negative pi over 2 negative 90? And then a radius of 2. So 1, 2. All right, the last one's kind of a brain buster. Look at this. It has a negative radius. What's up with that? So we're going to first rotate to pi over 4. Pi over 4 is how much? 45 degrees. And then when we count our radius, we're going to count, how do you count negative 4? You go the opposite way. So now we're not going to head towards the 45. We're going to head away from the 45. 1, 2, 3, 4. This is the point, negative 4, pi over 4. Yeah, there's lots of different ways that we could have named that point. We could have called it negative 3, we could have called it positive 4, negative 3 pi over 4. Right? So every point has multiple ways of writing it. Yep. Another thing we get to do, and this is probably the main benefit of polar coordinates, is it makes sweet graphs. Do you have a calculator on you? Because we're going to start typing some things in. Actually, you could probably do this in your head if you remember trig. I've completed a lot of this. Instead of an XY table, it's an R theta table. And I've completed a lot of it for you, but here's the idea. We probably want to be in radian mode. It doesn't matter if you're in polar mode right now, as long as you're in radian mode. Because we're just going to go on our main screen. We're not going to go to the graph section, just on your main screen. Can you type in 3 times cosine of 0? Or how many people know what cosine of 0 is? 1. So 3 times 1 is 3. And then I need to figure out what 3 times cosine of pi over 6 is. Cosine of pi over 6 is square root of 3 over 2, but I really kind of want the decimal version anyway. It came out to 2.6-ish for me. Let's try pi over 4, 3 times cosine of pi over 4. 2.1-ish. Okay, so we've made a table for that equation, yes? And now we're going to plot those points and see what kind of picture it makes. Is this exciting? Yeah. So the very first point I'm graphing is the point 3, 0, which means I'm going to be over at 0 the angle, and I'm going to come out 3. The next point I'm going to be up at pi over 6, and I'm going to come out 2.6. And I just keep going around. I'm going to go to pi over 4 from the table, and we're out at 2.1. My next point was at pi over 3. At pi over 3, my radius is 1.5. Are you seeing where I'm getting these points? Okay. So we're going to keep going. Next, I'm up to pi over 2, and a radius of 0, though, at pi over 2. That's just one way of writing the origin. 0, comma, pi over 2 would be just right here. But this is just a polar graph so far. Now it's going to make some sort of shape, and those have names, so let's wait until we get the whole shape on there. We're at 2 pi over 3, and I need to go out a radius of negative 1.5. That's backwards, you know. Alright, now my next point, 3 pi over 4, I'm at negative 2.1. I'm at 5 pi over 6, I'm at negative 2.6. And then I'm over at pi finally, and I go negative 3, and I actually get back to the beginning. It is a circle. So in polar coordinates, r equals 3 cosine theta is a circle. That's the equation for a circle in polar coordinates. And the circle is positioned in a certain way and has a certain radius because of that equation. Some graphs require you to do more, like probably up to 2 pi is the usual. I wanted to do a short one so we could just get the idea. Some graphs you need to go up to like 20 pi in order to get the full graph. In those cases, let's use our calculator. Can you grab your graphing calculator? Because the next thing I want you to do is actually switch to polar mode. Switching to polar mode. Now it doesn't technically matter if you're in radians or degrees, but I would probably suggest radians just because a lot of times I make our tables in 3 pi.
Lily, that's for you.
All right, good. The kids have noticed the polar bear on the screen. Good. All right, so we're in polar mode. Everybody success? Polar mode. Now when you hit your y equals, look at that. When you hit your y equals, we have an r equals instead. I'd like you to try typing in r equals 6 cosine of 2 theta. Don't type a 0, that's a theta. The theta button is just our regular x button. This time when you type your x button, the theta shows up. I'm going to suggest a zoom standard and watch that baby graph. Isn't that exciting? It makes like a flower. Now it's kind of awkwardly shaped only because our graph is stretched funny. So why don't you try a zoom square and it'll square up those petals nice and even. Isn't that nice? Are you ready for some more fun? Let's graph some other equations. You don't have to graph them all together or anything, but try this one. R equals 1/3 theta. This is a good one. You should see like a little snail shell almost, just a little soupy roundy. If you want to see, no, this is important. If you want to see more of this graph, will you go into your window and change your theta max? Because there's actually more to this graph that doesn't show up. Change your theta max to something ridiculous like 20 pi. Make it go round and round and round and round. And then when you graph it again, you'll get to see more of that spiral. So worth it. Isn't that enjoyable? Now, I don't suggest leaving your theta max at 20 pi because then every graph is going to take forever to graph. So if you want to change that back to 2 pi now, that would be fine. But try these other equations. They're super fun. If you want to pause and try those, that would be fine.